Okay, good morning, pre-calc. So today we're going to continue on with polynomials, but we're actually going to be kind of working in the opposite direction of the way we've been working. Up till now, we've been finding zeros of polynomials. Now we're going to try and create polynomials when we're given specific zeros. So the process isn't too difficult. We're going to start out with some basic ones where we just have whole numbers, like 1, 2, and 5 on number 1. And all we have to do is come up with the factors that would give us those zeros and write them out. So, for example, the factor that would give us a 0 of 1 is x minus 1. And then x minus 2 would give us a 0 of 2. And x minus 5 would give us a 0 of 5. And then to get our final answer, we really just have to multiply those factors together. So because we have 3 different expressions there, we're going to multiply 2 at a time. So first multiply these guys. X times x is x squared, and then we have x times negative 2 is negative 2x, and negative 1 times x is negative 1x, so that's negative 3x when we combine those. And then negative 1 times negative 2 is positive 2. And then to finish off, you're going to go ahead and multiply that trinomial to this binomial. So you're going to do x squared times x is x cubed, x squared times negative 5 is negative 5x squared, negative 3x times x is negative 3x squared, and negative 3x times negative 5 is positive 15x, and then you got 2 times x and 2 times negative 5. And to finish off, just make sure that you combine any like terms. And just like that, we have a polynomial that would have zeros of 1, 2, and 5. Okay, so go ahead and try out number 2 on your own. Pretty similar process. And you can pause the video now and then unpause it when you're ready to check your answer. So I'm going to just write out factors. And then I'm going to kind of skip over that and just give you the answer. It should be x cubed plus 5x squared minus 17x minus 21. Okay, so now let's look at a few examples where we have to think just a tad more. So on number 3, you'll notice we have a fraction. So the minus 2 and the positive 2 are pretty easy. That's just going to be x plus 2 and x minus 2. But then for that negative 4/3, we have to think what factor would give us that. And we kind of have 2 options on how we can do this. So a lot of people can just do it in your head, which in this case, we would just get 3x plus 4 as the factor. Okay. But if you can't do it in your head, what you can do is this. You can just set x equal to that 0. And then you can just use inverse operations to get 0 on the right-hand side. So for example, I would multiply 3 on both sides. And then add 4. And see how I got that 3x plus 4 on equals 0 once I've got the 0 on the right-hand side. And that tells me what that factor is. And then after that, it's just a matter of multiplying those out. So you do x plus 2 times x minus 2, that's going to be x squared. And then we got minus 2x plus 2x, those guys will actually cancel. So we get something like that. And then we would go ahead and continue on and just FOIL this. So that's going to be 3x cubed plus 4x squared minus 12x minus 16. Okay, so for number 4, you'll notice that we have a square root. With these guys, our process really doesn't change too much. You just got to make sure that you're pretty confident when it comes to multiplying with square roots. So the plus or minus tells us that we actually have 2 zeros right here. We have positive square root of 2 and negative square root of 2. So that's going to be x plus square root of 2 as well as x minus square root of 2. And then we also have x minus 1. So in this scenario, you got to make sure that you multiply these guys first. Because check out what happens. You're going to have x times x is x squared. X times negative square root of 2 is negative x squared of 2. And then we have square root of 2 times x is just going to be the exact opposite. And they'll actually cancel. And then to finish off, you got square root of 2 times negative square root of 2. That's going to be negative square root of 4. Or negative 2. So that one actually breaks down pretty easily when you multiply it. And then you would just finish off by FOILing. and you get your answer. Okay, so go ahead and let's have you guys try number 5 out. And you can pause the video, and then I'll go ahead and show you what this should look like. I would multiply these two and those two when I'm doing this. So this is going to be x squared minus 12. And this other one will be x squared minus 1. Looks like we get something like this for our answer. Okay, now I want to show you one where we're just dealing with a little bit more complex of zeros. For number 6, this first 0 is easy to just tell it's going to be a factor of x plus 6, but our second one is 2 plus or minus the square root of 5. So that looks like it must be something from like a quadratic or something that we got that 0. So with this one, I suggest you go back to that other way I showed you up in the top left here. So what that means is we would take x and set it equal to that 2 plus or minus the square root of 5. And our goal would be to get 0 on the right hand side. So the first thing we would have to do is subtract 2. And then to get rid of that square root, we're going to have to square both sides. Just make sure that you square the entire quantity x minus 2. So x minus 2 times x minus 2 is going to be x squared. Then we're going to have minus 4x plus 4. If you have to, go ahead and write that guy out twice and then FOIL it, just to make sure you get that correct. And then over here, we're just going to get 5. Okay? And then to finish off and get that 0 on the right-hand side like we're looking for, you would just subtract 5, and there you go. So what that tells us is that this expression right here is what would give us those zeros of 2 plus or minus the square root of 5. And then, as always, we just multiply it out to finish off. So that's going to be x cubed minus 4x squared minus x plus 6x squared minus 24x minus 6, and combine like terms to get your answer. It should look something like this. Okay, so dealing with multiplicity is actually really easy. All you have to do is just write that factor multiple times. Like for example, on number 7, we have 3 with a multiplicity of 2. So I'm just going to write x minus 3 twice, and then I'll write x minus 5 for that last 0. And then same process after that. I'm actually going to skip over multiplying that out. Okay, so go ahead and flip the page over. And what I want us to go ahead and look at to finish off are some situations where we have complex zeros. Okay, so if you look at numbers 11 through 14, you'll notice that we have I involved. One thing we have to remember is this conjugate root theorem, and it's actually pretty simple compared to what the name implies. So all we have to do is remember that if we ever have a complex number, like I, we have to take into account the fact that there's always going to be a positive or negative version. The only way that we ever get I is by taking a square root, right? So whenever we take the square root, we get that plus or minus. So if we have a complex 0 of a plus I, then a minus bi must also be a 0. So it's just saying that whenever we encounter I, we have to make sure that there's a plus or minus in front of it, even if it's not written. So for 11, we have 5 and 3i. I have to remember that it's actually going to be plus or minus 3i. So the zeros would be x minus 5. And then to figure out, and sorry, not the zeros, the factors. And then to figure out what the factor is going to be for plus or minus 3i, you got to do that little side work that I was just teaching you. Okay, so we say x equals plus or minus 3i. And then we're going to go ahead and we're going to get 0 on the right-hand side. So in this case, you might think, what do I do to get rid of that plus or minus 3i? And what you actually want to do is square both sides, right? And when you square, you're going to get 3i squared. And we all know that I squared is actually equivalent to -1. So that's going to just become -3. And then add 3 on both sides. I'm sorry, you know what, I made a mistake. That should be 9i squared, right? I forgot to actually square that 3. So then we're going to add 9 on both sides and get x squared plus 9 equals 0. And remember, when we're doing that side work, our goal is to get 0 on the right-hand side. And that's what we did. So that tells us that x squared plus 9 must be our factor. And then we would multiply it out. And then in this case, we got to rearrange it just a tad to make sure it's in standard form. And we got our answer. Okay, so go ahead and try out number 12. Make sure to add in that plus or minus for the 2i. And you can pause and then come back to it. I'm going to do a little side work with this one. So it looks like that other factor is going to be x squared plus 4. So first multiply these guys, and you're going to get x squared, looks like minus 6. And then we have this x squared plus 4 as well. And then just FOIL it. And you get x to the 4th minus 2x squared minus 24 as your answer. All right, and then the last one I want to show you is number 14. And this first factor is pretty easy to get. That's just x plus 4. But then you got this 3 plus I. And remember, we have to add in that plus or minus. And then I'm going to do some side work over here. We're going to have 3 plus or minus I. And we're going to set x equal to it. And then our goal to figure out the factor is get 0 on the right-hand side. So first I'm going to subtract 3. And then to get rid of I, I'm going to have to square both sides. And that'll give me, remember, this is x minus 3 times x minus 3. You actually have to FOIL it. It's going to give me x squared minus 6x plus 9 equals I squared, which is -1. And then add 1, and it looks like we're going to get something like this as our factor. X squared minus 6x plus 10. And then finally, go ahead and multiply this out, and you get x cubed minus 6x squared plus 10x plus 4x squared minus 24x plus 40. And then combine like terms to get your answer. Okay, so hopefully you have the skills to complete numbers 11 through 16 on homework 10. So 11 through 16 on homework 10, and this will be checked for homework tomorrow. I hope everybody has a great day.